Let's look at the last example. Starting from a circular paper of radius r, so the graphs are given to you already. So we have a circular paper of radius r, this is the radius r. We want to build a cone by cutting out the circular sector OAB, so we want to cut this part out with this central angle theta from the circle, and then joining the line OA, so joining OA and OB, so put them together, that's gonna give you this cone. Okay, so this right circular cone will be formed whose base is circle with a parameter equal to the length of the arc. So this would equal to this part. Okay, and you can see that this would be your OA or OB when they collect together, which means this part will be my capital R, and the height can be reduced from the illustration below. So this height, this h, to be honest, we don't really know because it's not really given to us, but we can find the relationship between this r and this radius, right? And then they ask you to determine the angle theta that maximizes the volume of the cone. Alright, so I need to maximize volume of this, and we know that the volume of this is 1/3 pi r, this radius, pi r square times h. So r, this small r is unknown, this h is unknown, so we don't really know much yet, but we can use what's given here to collect them together. Alright, so let's first let's see what shall we define variables? Actually most of them are defined for us already, so let's still define that V be the volume of the cone, R be the radius of the base, h be the height of the cone. The other ones are all given to us in the graph already. Okay, so now let's find the relationship between them. We already know that V, we know the volume V is 1/3 pi r squared times h. Okay, so this is what we know, but there are many things we don't know, so let's find the relationship between the other variables. So let's find what is the relationship between r, this h, this r, and this theta. Okay, bear in mind that the only thing that's constant here is capital R. So let me write it here. R is constant, this is fixed. But everything else, for example, this R and this H would change depends on how much you're cutting out. So if this theta is smaller, you might get a different value. So everything else will now be constant. R is the only constant we have. So now let's look at the blue arc, because this blue arc is basically this blue arc, so we can have some relationship. So now we can see that the length of the blue arc is basically, so it's basically this whole length minus this part, right? So that's basically 2 pi minus theta. The angle wise is 2 pi minus theta. So that's gonna be r, so the radius times 2 pi minus theta. Okay, so that's the length of the blue arc here, which is also the blue arc here, and can be represented in a different way, which is gonna be 2 pi r, small r, 2 pi small r. Okay? And also, this is one of the relationships, so we can highlight this. I can also find the relationship between this h, this r, and this r, because there is a triangle. So also by Pythagorean theorem, right, we have r squared equals to small r squared plus h squared, which means my h, because I need an h here, my h is just the square root of big R squared minus small r squared. Okay, so let's highlight this one as well. And as we mentioned before, now we wanna, this is what I need to, is it maximize? Minimize? Maximize. So now I need to maximize this value, right? So I need to write it as a function of only one variable. Here you have two variables, so I can sub this back into here so that I only have one variable, because r is a constant, doesn't matter. So let's call it 2. Let's call this 1. Sub 2 in 1. And we can have v equals to 1 over 3 pi r squared times h, which is square root of the capital R squared minus small r squared. Okay, so now this is what I need to maximize. So I can take derivative. So let's take derivative with respect to r. So v prime is gonna be 1 over 3. That's gonna be product rule, so 1 over 3. I'm just gonna put in bracket 2 pi r times square root of capital R squared minus small r squared. This plus pi r squared times 1 over 2 r squared minus r squared to the power of negative 1 over 2, because square root of this is basically to the power of 1 over 2. And chain rule, so multiply by 2, negative 2r. Okay, the whole thing multiplied by 1 over 2 because it's a constant. And now we can simplify it a little bit. That's gonna be 1 over 3. The first term, there is nothing to simplify, so let's leave it. R squared minus small r squared plus, so let's put this part at the bottom, right? This part, that's gonna be square root of r squared minus r squared. And top, we can see that this 2 and this 2, they cancel out with each other. So I will be left with a minus, so let's change this plus to minus. I'm gonna be left with negative pi r cubed. Wrong color. Negative pi r cubed. Okay. We want to set this to 0, so now it's not very clear what my r will be if v prime is 0. So I want to combine those two together, write it as one fraction, and maybe put the 3 at the bottom as well. So that's gonna be 3. Bottom is gonna be 3 times square root of r squared minus r squared, and top, I'm gonna have 2 pi r. So this whole term, in order to put on top of this, you need to multiply by this. So that's gonna be r squared minus r squared, and then minus pi r squared, pi r cubed, sorry. And you can factor out pi r, right? So let's write it here because I'm gonna run out of space. So 3 times square root of r squared minus r squared, and then let's factor out pi r. You'll be left with 2 capital R squared minus 2 small r square minus r square. Okay, so this is basically, we're almost done. Pi r times 2 r square minus 3 small r square over 3 root r square minus r square. Okay, so this, well, we know that this cannot be 0, of course, right? It doesn't make sense to be 0 here. Because if this is 0, then this equals to this, which is impossible when you have a right triangle here. So this is not 0, so a v prime exists within its domain, and also the top. Did I ever write the domain of the function? My bad. R. Oh, R has to be greater than 0 for example. Okay, so continue. And now, in order for this to be 0, which means your numerator has to be 0, we know that pi r cannot be 0 since r cannot be 0, right? Since pi r is not 0, in order for this to be 0, we need 2 capital R square minus 3 small r square equals to 0, which means that 3r square equals to 2 capital R square. So r square is 2 over 3 capital R square. And r is square root of 2 over 3 r. We don't need the -1 because, well, r has to be positive. Okay, so let me write it somewhere. Discard negative of this since my r has to be positive. Alright, and now we're almost done, but not really, because, well, first you need to check if when r equals to this, we actually have maximum v. Second, they're asking you for the angle theta, so even after checking that, we still need to find the angle theta. And you can see that there is one more thing we didn't use, so that's something we need to use to figure it out. So let me just add a page. Oh, okay, there we go. So let's do first derivative test, for example. So let me continue here. First derivative test, so let's check when it's 0, root 2 over 3r. So in those interval, is my v prime positive or negative? And if you check, you'll see that here is positive, this is negative, so it's increasing and then decreasing, which means this is a max. Okay, so by first derivative test, we can see that v reaches its maximum when small r equals to 2 over 3 big R. This is because we have unique critical point and no endpoint. But also we need to figure out what's my theta, so let's use what I have before, which is this equation that involves theta. So let's copy it down here. We know this. Oops. Okay, so we know this, right? So The rest is just you plug it in. So that means r theta is 2 pi. R is 2 over 3r. This is r theta. Oops, I wrote it wrong. Sorry. I wanted to skip step, but I forgot to do something. 2 pi r minus r theta equals to 2 pi r. So r theta moved to the other side will be 2 pi r minus 2 pi r. So 2 pi capital R minus 2 pi small r. And small r, we know that it's root 2 over 3r. Right? So in this case, you can find theta is gonna be over r, so that's gonna be 2 pi minus, what do we have? 2 root 2 over 3